This is acquire current user hashes without admin privileges. So please join me in giving Anton Sapochnikov a very warm welcome.
Hi guys. So what let's talk about? I will discuss common penetration testing case, what I expect to see during every engagement during my work. We will discuss some traditional techniques to gather credentials of a user and dive into SSPI. So who is me? A little bit of penetration tester for some years. CTF player, maybe you know, my team is most smokedly chicken. There is no common with cannabis, as you may. But anyway, working for KPMG and project Volema. So, let's start. Let's imagine a situation where we don't have, we exploited some vulnerability in client-side software, for example, browser or I don't know, Flash player, or maybe user just downloaded and executed our payload from the internet, and there is no access to internet from his computer. I mean, without proxy, for example, or there is some kind of restrictions on it. And of course, we have shared access to user workstation because our payload was, I don't know, from Metasploit framework or some kind of it. And the user running fully patched Windows, any kind of it from XP to the latest 8.1. And of course, we don't have any privileges on that workstation. I mean, the user running under credentials of a user. So the admin working have done. Admin job was done. So our goal was to find, and our goal is to find out the password of a user and try to use it some way after that. Why do we need to try to get the user password? First of all, any shells gonna die. From day to day, we use buggy software. How many of you see Metasploit Meterpreter unexpectedly dying? So I see it every day, unfortunately. So workstation of a user may be powered off, for example, during day off or weekends, or maybe your attack was detected and forensics people starting to investigate the computer. So your shell will die and you will have no access to workstation after that. But if you grab a password of a user, you can use it to connect to, I don't know, webmail, Citrix, VPN, Exchange, any corporation, any corporate sources, what is available from the internet. What's the traditional ways to get the passwords of a user? Very famous tools like PVDump or maybe, you know, Mimikatz or Windows Credentials Editor, or maybe you just extract passwords from, I mean, not passwords, but hashes of passwords from a registry or SAM file. But the disadvantages of those ways is that you have to have admin privileges, for example, to grab registry or some debug privileges to extract hashes and passwords from a memory like Mimikatz or FGetDump do. If you remember, during definition of our task, we don't have admin privileges on our workstation. So we can't use those tools to perform our engagement. The second way could be try to elevate privileges some way. For example, try to find some third-party service with weak file permissions and overwrite some sensitive files, or perform DLL hijacking attacks or something else. But as I mentioned before, we have fully patched operating system with fully patched services, so still no way to escalate privileges and exploit it and use our favorite tools like Mimikatz. That's set. There is some kind of alternative ways. For example, we could try to pop up a window that could look like that. It's a standard window from Windows XP, but as you may mentioned, there is some letters in the Russian. But just imagine what if you're exploiting the computers that are staying somewhere in Russia or China, you couldn't pop up a window with the correct words in with the correct letters, so a native speaker will mention it with those letters and will not trick, and he will not enter his password in that window, so you'll fail. Anyway, even if a user will believe to your window, he may, for example, enter some different words what are not actually usernames or passwords. During my experience, during my engagements, I see a lot of users were trying to put, for example, some words like, I don't know, get off or something like that. If they actually realize that it's some kind of social engineering attack, the user could try to have some fun with you. I don't know. But the second way could be, for example, use of the script from Metasploit framework, what actually called hash snarfing. Also, this technique is implemented in the tool called Incognito. How it works? The approach is running under credentials of a current user, trying to connect to SMB server what is running somewhere in the network, in the local network, and authenticate on it using the credentials of a current user. And the attacker should control that SMB server to grab the credentials and somehow extract the passwords from it. But as I mentioned, in the definition of the task, we have no access to the network, so we do not have any SMB servers in the networks, and we can't execute such kind of attacks. The third way is try to use Internet Explorer. The default browser could use credentials from a current user to authenticate you, and you also could grab the hashes, but there is some disadvantages. For example, the host name what you should browse with Internet Explorer should be located in the trusted zone of that domain, and that means that it should be located in a local network where the user is currently located. That's option number one. Or option number two is that you could change the proxy server of the browser, and for example, the proxy server will be actually your server, and the whole traffic from the browser will go through that proxy, and you could capture the hashes. But it's quite difficult to perform, because actually you could block the whole internet access a whole internet for the user. And as you know, if the internet doesn't working for the user, he will call help desk, and your shell, your Meterpreter or something, I don't know, Core Impact or another tool will be killed, and you'll be your incident will be investigated. Anyway, if you want to follow the way of using Internet Explorer, all of you know that if you are executing internet browser, it will use a lot of resources, and it will be very, very slowly, and the user will notice it. So I think that alternative ways are not for us, at least. So what is the security support provider interface? It's some kind of a layer what allows different applications, starting from browsers, any kind of applications, to talk to security providers what are implemented by operating systems. So what is it? There is several packages. The simplest of them is Microsoft Negotiate. It just picks the best security package to handle the current configuration of a computer and try to use the package what are actually configured by admins. The second package is Microsoft NTLM. Everybody, I think, know what is it. Microsoft Kerberos and Microsoft Digest SSP. Digest SSP currently not widely used, but in the past it was used to authenticate users on the mail systems like POP3 protocol, or for example HTTP digest authentication. And the secure channel package, it's just the implementation of SSL or TLS by Microsoft. So how any application would talk to any server using SSPI? For example, we have a client application and the server application. And the client would like to authenticate on the server using password of a current user. It will exchange on initiation some kind of messages, and anyway, client should generate the message called NTLM negotiate and send it to the server. The main advantage of a SSPI interface is that client application shouldn't know anything about what NTLM negotiate is. It just tell SSPI, please generate me that type of message, and then client just get it from a buffer and send it to the server without any modification. On the server side, happens the same. Server will talk to SSPI interface and with the following: hey SSPI, here is the message from a client. Copy it from buffer from that buffer and generate for me please NTLM challenge, and I will send it to a client. After that, client will receive NTLM challenge message, also will send it to a SSPI interface, and SSPI will prepare for the client the message what should be sent to the server. So SSPI allows us to abstract from what is the current of implementation of different mechanisms currently running on your operating systems, how it runs, what options are there configured, where is the main controller, or then I don't know what's the current, where is located, how many of them. Just ask SSPI to perform authentication, and that's all. So there is three types of messages, as I told before. Message type 1, it just contains features what are supported by the client. Message type 2 just contains features what are supported by the server, and it contains a challenge generated by the server. The challenge should be used to generate the message type 3, and the hashes what are contained in the message type 3 are calculated using the challenge from a message type 2. So let's optimize approaches. To attack the SSPI, we should, for example, implement the server and the client application in one process. What does it mean? We will send the message type 1, message type 2, and message type 3 from client to server in one application. That means that application actually know what is the challenge, what is sent to the server, and what was captured by the client. So there is no any traffic on the network, and the attacking application could grab all that information what was passed and use it somehow to calculate and extract later some hashes. So how it looks like? Message type 1 it's different bytes, and using that we could extract the nonce, the challenge, the hashes were calculated by the challenge, and if you grab all the things, you could just format it for different crackers, for example, John the Ripper, and it will crack it for you. And after a little bit of brute forcing, you will get a password of a user. I did a little bit of benchmarking. As you can see, if you are using different types of protocols for authentication, for example, HTTP digest, you can brute force as fast as 1 million hashes per second. If you are currently using NTLM version 1, it's about 2 million hashes, and NTLM version 2, it's about 500 hashes per second. What does it mean for us? It means that if NTLM version 1 is disabled on the computer, we could try to use HTTP digest to authenticate the user. That will allow us to brute force later on a double speed. So what the attack flow will actually look like? The pen tester will send the user some kind of spear phishing. User will be navigating, clicking on the link, or I don't know, downloading some payload or exploit it anyhow. The payload will try to authenticate the user on itself and send the authentication data, what was extracted from the data flow, to the pen tester. The pen tester will brute force it and extract the username and password of a user. After that, he will use that to connect to any corporate resources and exfiltrate the data, what means that penetration test was successful. How we can exfiltrate, how our payload can send the message to our command and control center with authentication data what was just extracted. Well, there is, I think everybody of you know some kind of reverse shells, or connect backs, but it's quite often blocked, and I would like to present you with two following ways. The way number one is using DNS for it. For example, we could try to ask the DNS server to resolve for us some kind of name, like some information goes here to my.evildomain.com. That means that our DNS server that is running on that domain will capture the data what was requested. But every time your payload will try to resolve a domain, Windows Security Alert, for example, or any other personal firewall will alert that, and the user may block your payload. There is some workarounds for it. For example, for a workaround, what I suggest you is using file system. For example, Windows API like create file or set current directory with way like / some information goes here my domain / some directory will force the operating system to resolve a DNS name for you, and it will send the DNS request to your server, and the personal firewall actually will not block it, and that means that you'll win. If you would like to get some information back from a DNS server and not using any network connections, you, for example, you should use, for example, ipconfig / display DNS, and you will see that there is a lot of DNS replies that are cached by DNS client for you, and you could extract from there, and actually there is no any personal firewalls that will catch you doing such things. It's slowly, but if you want just to send a username and password to somewhere in the internet, that speeds quite enough. The second way to send the username and hashes what you just grabbed to your command and control center is using Google. Many times during my penetration testing work, I see the company was using some kind of whitelisting on their proxy servers, and they block any unknown websites. But Google.com quite often is opened for everybody, even for guests of a company, even for the most unprivileged users. So we could try to use it to send data back to home. The trick is using the IPs of Google.com and try to ask Google.com to send the data to the application engine of Google. So to perform that attack, we should install our own application engine, and that will capture the data and send it to somewhere else where we actually could brute force it. And using that way, any proxy server that is monitoring the internet of users could see that the user just searching something in the internet and nothing else. So we will win after that. How could we mitigate those kinds of attacks? First of all, we could try to use two-factor authentication, any kind of hardware tokens or software tokens, strong passwords. As you mentioned, we should brute force hashes what we just grabbed to extract a password. So If a password was quite strong, we will fail and the password wouldn't be extracted. And the last suggestion is just to try to disable unused packages. For example, as you see in the benchmarking slide, here is it. HTTP digest package allows you to double the speed of brute forcing the passwords. So if you disable it, the attackers will use only the NTLM version 2nd to attack your users. That will harden it. So what's next? In a week I will release a Metasploit post-exploitation module, the implementation of attacks, of the current attacks written in a C currently on a GitHub, but the Metasploit model is currently in a work. It has some bugs. For example, it doesn't fully support a protocol and do not extract hashes from every operating system. I know it, at least I know where is hashes, but it's difficult to extract because RFC for that protocol is about 100 pages, so I don't have time to read it full. And I don't know, something else to improve. So that's all. I am ready to maybe answer your questions.